All right, so let's start with graphing quadratics. So if you look at a quadratic online and the regular shape of a quadratic, if you say type into Google Images, most of you should know that these look like parabolas. So if you see a quadratic question, in a quadratic question you already know, you should know because the highest exponent on this is a 2. So this is a quadratic. If it's a 3, we have a cubic. So it should either look like a happy parabola or a sad parabola. So looking at the questions for the test, you should at least have an idea what it should look like. All right? And there's no breaks. It's one continuous line. So if we come here and look at this, we have this function here. Okay? And for this, we just have to put in these points for h. So fill in t, given -1, 0, 1, 2, 3, 4, 5, 6, and you should have your h. For example, h is equal to, well, if I want to use the point -1, we have t squared, so -1 squared, minus 5 times -1 plus 4. So all you need to do is insert, try that again, one more time. There we go. So all you need to do is insert -1 into this function here. And you can use this and do this on your calculator. And you should get, if you do the work, let's see, -1 squared. Be careful, don't do -1 squared on your calculator. That's different from -1 squared, okay? This gives you -1. This gives you +1. Okay, and changes +1. There you go. A little bit thicker, my brush. All right, so -1 squared is 1. -5 times -1 is +5. So if you have 1 plus 5 plus 4 equals to 9, 10. So at this point, you should have 10. So you for sure need your calculator to do these ones. I have all the other ones listed out here. So for 1, I got 0. For 2, you should get -2. For 3, you also get -2. For 4, you get 0. For 5, you get 4. And for 6, you get 10. So we are supposed to plot in between -1 and 6. So anything past this point here, we don't really care about. For any t that it's less than -1, and anything past 6 here we don't care about. So our graph should be in between -1 here and 6 somewhere. All right. So now I'm going to start plotting my points. So -1, 10. Wow, that's way up here. So I'm like maybe up here. This is a really high point. I didn't notice that the graph was too small. So let's try the other points and see how they look. 0 is at 4. Okay, so this is the 0, 4. Got that one, got that one. Next, 1, 0. So 1, 0 is here. And then I have 2, -2. So 2 and -2 is here. And then I have 3, -2, which is almost the same spot. And then we have 4, 0, which is here again. And finally, the last two, 5, 4, so 5, 4, and then 6, 10, that's off our chart again, so if I go up here, it should be like up here somewhere, okay? So, we've plotted these here, we put the points, okay? Just going to erase this because we don't need these marks here. Now, if you look at that, that looks kind of like a parabola, right? Like a U here, okay? So if I were to draw this, the question is, how low does it go? Well, these are the two center points here, isn't it? Okay, so it's got to be somewhere, the lowest point has got to be somewhere in between here. So if I try and draw this with my digital pen, which is not so easy because it's sideways. Let me try this again. That's if I draw it really quickly. And then let's try it again this side. Obviously it doesn't work so well. Let's try if I use one of these things. Whoa, almost. I keep pulling. Ah, look at that. Something like that there. Perfect. So that's what your parabola should look like, going through all these points. Okay? So you have to graph all the way to the end of this point and this point because of these here, -1 and 6 here. Okay? All right, for the second piece, we have this question here, B. What are the coordinates of the lowest point on the graph? So that means the lowest point, and if you look, it should be somewhere around here according to my drawing graph. But how do you know exactly where it's going to be? Well, if you look at these 2 points, 2 and 3, you get closer and closer. It's got to be somewhere in between here, because remember that with quadratics, you have this line of symmetry that cuts this thing perfectly in half. Let me try this again. Something like there. So it should be a mirror of itself. So this side looks exactly like this side. So if these are the 2 points getting closer and closer to the bottom of this parabola, 2.5 has to be in between these 2 points. So the lowest x point, just by looking at the symmetry of the graph, the lowest x point has to be equal to 2.5. And because you have the x point now, we can look at the h point. So in our example, this is not x, we have t, and this is not y, we have h. So it doesn't matter which letters they are, but in this case our y-axis represents h and our x-axis represents t. So this 2.5 is actually our t. And if you want to find the h, all you need to do is plug in this value into your function here. So 2.5 squared minus 5 times 2.5, all plus 4. And if you do this on your calculator, you should get, let me check, it becomes negative 2.25. So let's see if that's about right. Yeah, that's about right. Negative 2.25 is about there. So to write this as your final solution, if they ask you for a coordinate, you always have to write it in this form here. 2.5 comma negative 2.25. Okay, so that's our coordinate, xy. All right, so that's part B. What is the equation of the line of symmetry? Well, this is the line of symmetry here, right? This line that cuts us perfectly in half, this is called the line of symmetry. Okay, and the line of symmetry, the equation for that always should be x is equal to something. And it's x is equal to the number on the x-axis that cuts us in half perfectly. Well, we figured out that already, or haven't we? We figured out that x is equal to 2.5, or t, pardon me, is equal to 2.5, cuts this perfectly in half. So for this bit here, for part C, when it asks you for the equation, when it asks you for the equation of the line of symmetry, or pardon me, the equation of the line of symmetry, all you need to do is find the middle point that cuts the parabola in half, and that's the x point that gives us that number. Okay. Part D, it says use your graph to find the value of h when t is negative 0.5. So where's near 0.5? So if I look at negative 0.5, it's roughly around here, isn't it? So if I go up, you should get maybe around 6 if it's quite accurate. And then you can always check with your calculator by inserting the point negative 0.5 into the original equation here. Okay, so I did this for fun just to see what it was. And at x is equal to negative 0.5, I get y is equal to 6.75. So my graph isn't completely accurate. But that's all right. That's hard to do here when you're drawing this. So 0.5, 6.75. Well, it's a little bit higher than that, isn't it? It's about right there. So yeah, I guess it could be that there. So this point here. And then finally it says, use your graph to solve the equation t squared minus 5t plus 4 is equal to 3. So they want to know when this graph is equal to 3. Well, all you need to do is plot this y is equal to 3, okay? So it's like this is its own function. So you should be able to plot y is equal to 3 here. So y is equal to 3, well, that's this line here. Okay? That's the line where y is equal to 3. Okay? And now, in order to solve this, if you ever want to solve an equation where you have one function equals another function, you just figure out where they cross. And look, this crosses here and this crosses here. So those are 2 points in where you can get a t for these two to equate. So the intersection of two graphs gives the solution for t. So at this point, what is our t? Well, t is at 0, isn't it? So for part E, t is equal to 0 is one solution because they cross at t is equal to 0. And the other solution is t is equal to, I would say around 5. Okay? So just to verify, I used a calculator and I get values of t is equal to about 0.2, 0.209, so quite small, close to 0. And on the other value, I get t is equal to, was, let me see now here, 4.79, which is quite close to 5 as well. All right, so that's how you do graphing a quadratic and answering a few of the questions for a quadratic.